I'm very pleased to welcome a more or less new colleague of us today. As a speaker, it's Hendrik Mahlkow, and he joined the WIFO since the beginning of this year. Hendrik holds a Master in Science in Agricultural Economics from the Humboldt University of Berlin. And actually, he's doing his PhD under the supervision of Gabriel Felbermeier. So Hendrik's research focuses on international and environmental economics, and he's using quantitative trade models based on gravity models for his research. So today he's going to present his work on carbon footprint of global trade imbalances. And the presentation will take about 30 minutes. And after that, our colleague Anna Renhart will provide a short comment, which will take about 10 minutes. More and more people are joining us. That's perfect. Well, so in the end, that leaves us with about 20 minutes of discussion time. Don't forget to mute your micros for all of whom which you're virtually in room. And well, that's it from my part at the moment, please. So the floor is yours, Hendrik. I'm going to switch chairs such that everybody's going to see you.
Hello, everyone. Nice to be here. And you'll just try to set me up. But
do you want?
I will manage.
Then 5 minutes are left, or
hopefully I won't need
perfect
all 60 minutes.
Like that.
But please do so if it's only 5 minutes left. Then I probably have some problems, but we'll see. Yeah. Hi, everyone, and welcome from my side. Today, I will present joint work with Joschka Banner. First, I try to get in the full screen. Yeah, thank you. I present work on the carbon footprint of global trade imbalances. It's together with Joschka, who's now, he moved a couple of weeks ago to University of Würzburg. He was formerly in Potsdam. And what motivates our topic is that the embodied emissions in international trade are highly imbalanced. And so is trade as well. And the question is, if trade imbalances, if aggregate trade imbalances, do they have an overlooked environmental impact that hasn't been studied yet? And this is something we wanted to explore. And at the beginning, I will show you some graphs. Here you see the bilateral flows of, isn't it shared? Okay. Yeah, okay, now. So this is the first slide, so the audience hasn't missed anything. These are the embodied emissions in international trade, and what you can see. So this is for the 6 largest countries of the 6 with the largest embodied emissions in exports. And what you can see is they account together for 66% of embodied emissions in trade. But only on 53% of their imports. So there's already in the aggregate is an imbalance. And when you look in the specific countries, for example, China, they have the biggest surplus in embodied emissions. They export around 2,100 megatons embodied emissions. And in their imports, it's only, let me see, 840. So less than a half of the emissions embodied in their imports than embodied in their exports. And the other way around is for the United States. They export 450 megatons, but import more than 3 times or almost 3 times, it's to 1,300 megatons are embodied in their imports. And this is for the year 2014. And when you look on the panel, you see that this pattern is quite persistent. So over the whole time, the US were always the country with the biggest deficit. And China overtook Russia around 2003, and was back then was the biggest was the country with the biggest surplus in embodied emissions. And this persistency is important. So, like, if trade imbalances play a role for these embodied emissions and for global emissions, then this persistency makes clear that this problem won't go away soon. And therefore, when you look at the trade imbalance in value terms, you see a similar pattern. This is for the six countries with the largest absolute trade imbalance. 5 of them have a trade surplus, and the US has a trade deficit. And you see that it's a little similar to the embodied emissions, even though not as severe. So China has aggregate their exports account for, or their trade imbalance is around $580 billion, while followed by Germany. Germany has a trade surplus of 390 billion. And then the opposite is the United States. They have a trade deficit of 480 billion US dollars. And this pattern, again, when we look at the panel, there's a little more movement as for the embodied emissions, but it's again the United States are persistently the single country with the largest trade deficit over time, and China overtook Germany around 2007 as a country with the biggest trade surplus. So trade imbalances, as you see, they are persistent in value terms.
Yeah. Question. This graph and also in the graph before, do you know why there is drop of the United States around 2005?
Drop. You mean like the lowest point?
It's a decrease and then it returns, and here as well.
No.
Do you know that? No.
I have no clue. I only see the spike around the financial crisis 2009, but I have no clue what was the reason.
Okay.
Yeah, so trade imbalance in value terms, but also in embodied emissions. And the question is, do trade imbalances allow for specialization and consumption patterns that magnify the global carbon footprint? And in order to have a first glimpse into if this might be the case, we did a very simple graph, which is where you see a lot of noise. Each dot represents one country. You see 140 countries. It's the GTAP database. And on the x-axis, you have the relative trade imbalance. And on the y-axis, you have the emission intensity of their exports minus their imports. And you see that there's a positive relation, even though a lot of noise, obviously. You see a slightly positive correlation that countries that tend to have a positive trade like a trade surplus, that their goods are that their exports are less carbon intensive than their imports. No, the other way around. That their exports are more carbon intensive than their imports. So when you see the countries with the biggest surplus and the biggest trade deficit, China and the US. China, their exports are quite carbon intensive, so I think they are around somewhere here, while the US is somewhere around here. Obviously, a lot of noise, and we're still in the process of figuring out if we can get this graph a little bit more appealing for the eye. To bin the countries or something, but yeah. So there seems to be a weak correlation between trade imbalances and carbon intensity. But another thing that's important, so trade is not only about the emission intensity of the goods that are traded, but also about the goods that cause carbon emissions, namely fossil fuels. And therefore, when you look into the largest fossil fuel exporters, 9 out of 10 or 8 out of 10 are running trade surplus quite substantially. When you look at Saudi Arabia, Russia, Qatar, Kuwait, and this trade surplus enables them to export more to the world market, more of their dirty goods that cause carbon emissions when they are burned, than when they wouldn't be allowed, or when they couldn't export as much as with their trade surplus. International trade allows for decoupling of where fossil fuels are extracted, where they are burned to produce goods, and where they are consumed. A balanced trade puts a limit on this ability on these kind of decoupling, while imbalances, aggregated trade imbalance, soften this limit, as they allow for a partial decoupling of how much a country buys versus it sells overall. So this comes to our research question: do current global trade imbalances reinforce environmentally detrimental specialization patterns? And in order to answer these questions, you need to build a model, and we did. And we built a quantitative general equilibrium trade model and simulate the effects of a rebalancing, because you do not know a priori where global production patterns, how do they shift worldwide when you limits a country's ability to run, or when you balance a country's trade. So how does this relate to the existing literature? There's not much work on the environment of trade imbalances. There's one paper by Lee and co-authors who look into the bilateral trade imbalance of the US and China and what environmental impacts it has. So we add to this, obviously. There is one seminal paper on the consequences of removing trade imbalances. So we are not the first doing this. There was a paper of Deckel, Eaton, and Kortum, I think it was AER 2007, who looked into the welfare impacts of balancing trade. And what we do not do is to look into the sources of trade imbalances. So we do not do thought experiments on what causes the imbalances. But yeah, we add to the literature on the growing literature on the international carbon emission accounting, and in general on emissions in new quantitative trade models. So let me introduce you to the model, a little bit of math. We built on the quantitative trade model of Eaton and Kortum 2002. It's a Ricardian trade model. We have trade between n countries indexed by lowercase I and n in multiple sectors with input-output linkages, as in the work of Cayeno and Paro. We add 3 different types of sectors, or we add two additional types of sectors to the overall set J. We have primary fossil fuel sectors P, secondary fossil fuel sector S, and all others. Our preferences are classic Cobb-Douglas. We have.
Sorry.
Yeah.
Can you tell the difference between primary and secondary fossil?
Yeah, I will in a second. Yeah, we have production. Goods markets are perfectly competitive, and all sectors use labor and a composite intermediate input bundle. So therefore, we have I/O linkages in the model, but the primary fossil fuel sectors, they use additionally a natural resource, and primary fossil fuel sectors are the ones that are without manufacturing, that are crude oil or coal, for example, while secondary fossil fuel sectors are the products further down the supply chain, like petroleum, which needs to be manufactured out of crude oil. And the secondary fossil fuel sectors, they require a fixed quantity of primary input, of a primary fossil fuel input, as this example of crude oil for the petroleum production.
So you assumed, or you chose a benchmark to order sectors in S sectors and in all other sectors.
So we have
a specific benchmark.
We use it comes from the data we use. We use the GTAP database. I will introduce you in a second, but can already tell you now. So GTAP has 5 fossil fuel sectors, and 3 of them, we will see it in a few slides, but it's basically that crude oil is a resource that doesn't require any other fossil fuel to be produced. I mean, it requires inputs like from machineries and to dig it out, but in order to process it, you do not need to have it's a raw fossil fuel. And while petroleum, you cannot, it needs to be manufactured in a plant, and in order to get 1 unit of petroleum, you need this and that amount of crude oil to be produced.
No, I understand the definition of P and S sectors, but I was wondering what this fixed quantity really means. If it means, okay, I need a certain amount of fossil fuels to produce whatever in that sector, and whatever amount is below this would be ordered in another sector, because I mean, I could imagine a lot of sectors would need somehow fossil fuels, but
no, do I understand it correctly? You need a certain amount of crude oil to produce 1 liter of diesel, for example.
Yeah.
And that's a fixed relationship between crude oil and the output of the fossil fuel product.
Yeah, exactly. But what if you have another sector that also needs a fixed amount, but a very small amount of crude oil to produce something? Is it?
I can tell you. So the normal production function is Cobb-Douglas. So we have you can substitute between inputs. So you can even substitute. So like all other sectors also need some primary and secondary fossil fuel sectors as their inputs, but you can substitute between them. While for the S sector, we have a Leontief production function, so there's no substitutability. So you need a fixed amount of the primary sector, which is also like we tell the petroleum sector needs crude oil, and there's a gas manufacturing sector that needs natural gas. It's not that it's a fixed link we supply. It's not that you can substitute between the primary sectors. You cannot substitute between natural gas and crude oil to produce petroleum. You need crude oil to produce petroleum. Yeah,
I think that's perfectly understood. But Agnes was asking was like, do you, for example, for chemicals or plastic, you also have kind of Leontief style crude oil?
I mean, that's the assumption. I mean, there was a debate last year quite extensively if we have Leontief production in producing chemicals, and we do not have it in the model. In the model, it's contactless. So all other sectors are contactless, and which have a nested CAS function. So the intermediate inputs are in a nested CAS. So we have substitutability between, but not for the secondary sectors. And then it's a trade model. We have international trade. Consumers and firms source goods from the cheapest supplier, and they face iceberg trade costs, T. So you need, in order to receive T units of a good, you need to ship T plus something. It melts on the way, therefore the iceberg analogy. And this gives rise to a sectoral gravity equation of bilateral trade shares, P. So P, the trade share of the good J from origin country N to destination country I is equals the expenditure of country I on J goods in N over all. No, I mixed the notation. So N is destination, I is origin, over N's total expenditure for J goods. And this depends on a productivity draw of the Fouché distribution, and the distribution, the productivity distribution is influenced by capital A and phi, not phi, theta, which captures the level of dispersion of productivities. So A captures the location parameter of the distribution. It's the absolute advantage of a country, and theta captures the shape parameter of the distribution. So it indicates the comparative advantage. So comparative advantage is determined by technology, geography, and factor endowments. What do I mean with this? We are more likely to ship to N J goods in the sector J when we have low production costs. We are very productive. C, low production costs. When we have low trade costs between us, small t. And when we are relatively when our productivity is relatively high. So then trade is balanced in the model in a way that we can only buy as much as we sell, despite that, here comes in. We can. This is relaxed by the trade deficit. So the amount we sell is not necessarily the same amount as we buy, because it's decoupled by so-called. So you can say it's kind of decoupled by the trade deficit. And this D is something we take away in the model. So we limit the ability to the country is not allowed to buy more than it sells to all others. So carbon emissions in the model occur whenever secondary fossil fuels are used, either as a production input or for final consumption. So either it is used to produce goods or to drive a car. We consider three ways of capturing a country's emissions. First is the production footprint. So where are the fossil fuels burned? The second one is the consumption footprint. Where are the goods consumed and what carbon emissions are embodied in these goods? And the third is the extraction footprint. So where are the primary fossil fuels being extracted? So trade imbalances are potentially problematic in a way that.
Excuse me, what is the difference between the production emissions and the third one? Because the third one should be covered in the first one.
So it's an accounting question. So
exactly.
the first,
that's what I mean.
The first is only whenever you use fossil fuels, when you use petroleum in the production to produce goods, then it's accounted to your country, to your footprint. Yeah, while exactly. The petroleum doesn't need to have to be sourced from your country. You can buy it from somewhere else. The petroleum comes from Saudi Arabia, for example. But in the production footprint, you produce something here, burning fossil fuels coming from Saudi Arabia. Then it's in this accounting for the production footprint, it accounts on your carbon emissions that you cause because you burn it.
Sure.
But the third one is it accounts for Saudi Arabia because Saudi Arabia digs out the petrol, the oil.
This is then the consumption footprint.
The consumption footprint is where are the goods consumed. You produce a good, this is then shipped to Germany. In Germany, it is consumed. Then the consumption footprint accounts for the emissions embodied in the good. You cost burning them, and Saudi Arabia costs them extracting it. And this is the three steps. Yeah.
Are the consumption footprints the trade costs allocated to the consumers? Because something melts away, so there's and their trade costs are borne by the consumers, and then they should be attributed to the consumers.
Yeah.
Yeah, they are. Yeah, international trade is always a little tricky in the models because you do not have, because of this assumption of iceberg trade costs, we do not have a modeled. I mean, we have a sector,
in a sense, you have the consumption plus the trade footprint.
Das war unser Fehler, ich habe ein bisschen zu lange warten müssen. Bitte schön, ja. Bitte.
Because the transport mode is part of the used intermediates to produce a good, it's accounted to the consumption footprint. Trade imbalances are potentially problematic because deficits of countries with relatively high consumption footprint, when you think about the US, for example, and surpluses of countries with a relatively high extraction footprint. So therefore, we think it's interesting to look into these three different accounting measures. The data we use comes from the Global Trade Analysis Project. It has 141 countries and regions, covers 98% of world GDP. It has 65 sectors. 5 of them are fossil fuel sectors, namely coal, oil, gas, petroleum, and coal products, and gas manufacture and distribution. This is what I said. So petroleum is the primary, is the secondary fossil fuel which needs oil as input in the Leontief function, and gas manufacture and distribution needs natural gas as input. While coal is both. You can burn coal right away. It's primary and secondary. It's in its own. All model parameters are sourced from this database. So the input coefficients, trade shares, value added, and also the initial trade imbalances. And also the carbon intensities of the different fuel types. So we source all model parameters from the GTAP database, despite the trade elasticities. They come from the literature, from recent paper of Fontanier and co-authors, and for the service sectors, because this is, as a few of you probably already have experienced by your own, it's very hard it's almost impossible to estimate them. But yeah, there are some guesses, and we take it from the literature from Ecker and co-authors. So now finally some results. What happens when we remove the imbalances? So we do two lines of experiments. First, we remove the individual's country's imbalance separately, one after another. So we have 141 countries, we have 141 scenarios. And the second one is what happens when we remove them simultaneously. So this is the first scenario, like the 141 scenarios in one graph, and you see what happens.
Explain what it does mean to remove the.
Yeah, it means that when the United States have a high deficit, then we set it to zero.
What is the response to this?
We set it to zero. We distribute the deficit among. So we reduce the surpluses of all countries relative with the relative share of the US trade deficit and overall deficits. So we reduce all surpluses a little bit, and so therefore in total it sums up to zero again. So like global trade sums up to zero again. Yeah.
That's the equivalent of a reduction in consumption and intermediate goods, isn't it?
It's a reduction in trade, or it's an increase, it's a reduction in imports or an increase in exports? That would be an interesting question.
Or in domestic production.
Exactly.
Yeah, but this is exactly what so we do not know a priori. We do not know whether it's so it's probably it's all of it. I mean it's all of it. So it's a reshoring. So we have less imports, probably more exports, more local production, a little bit less consumption.
Okay.
This is all of it, and we do not know. And the model, therefore, we build the model.
That's endogenous. So.
Yeah, I mean, the whole reshuffling is endogenous. So everything, and now we can analyze what happens. So what happens for consumption, production, trade. But it's a lot of numbers, and I won't show them to you because I only focus on the environmental impact. But this is also because this is very similar to what Deckel, Egan, and Corton did when they looked into the welfare impacts of trade imbalances. But in the paper, we also have we look into the trade effects and in the production effects. So, but this now, so I only show you the numbers for the emissions. What's it?
Just ask one more question. So firms are still sourcing from the cheapest source, but they are forbidden to source from foreign countries.
No, they source from foreign countries. It's just that when you're running a trade deficit, you can import more than you have to export. And now you have to import as much as you export overall. So your ability to import more than it's sustainable, so to say, is now gone.
The optimal cost-efficient choice of input is now more restricted.
It's more restricted. Yeah.
Have higher cost maybe, or
It's high. It's I know that then when you limit the ability to import, when you have to import less, then you produce more of your consumption basket on your own. So you have to source more of the needs of the consumers from your own.
but you lose some of the productivity gains of trade.
Yeah.
Sorry.
Yes, and it also assumes that you have all the necessary production factors at home.
I mean, you can, not necessarily. I mean, this is also, you can debate about it. You can also we can think about different production function. It's productive. We can add more frictions. We can also add more. So the key assumption of the model is that, therefore, it also has a long-term horizon that labor can move freely between sectors, which is probably, which is in the long run probably a realistic assumption, but obviously in the short run it's impossible. You can also. So I also played around with frictions, limiting the ability of workers moving to another sector. It's more costly. Yeah.
So the imbalances are including it's just goods trade or service trade in there?
It's both.
Okay, because what I understand is that the big trade imbalances for the US are partially offset by huge surpluses in services, no?
Income.
Not those?
Income.
They just get the money back from Ireland after it's
Yeah, but it's a dividend payment, and it's not a payment for a service.
after it's tax washed. Okay.
It's showing up in income payments.
So, but
that's tax-based.
what do I see here? I see
Patents are-
if the trade imbalances of the United States would be removed, then South America would reduce.
No. So this is a map for 141 scenarios. So you see the color in each country indicates what happens when we take away their corresponding imbalance to global emissions. So what you see, biggest effect is when we limit the United States ability, when we take away their deficit, then global emissions decrease by around, what is it? I know it's Qatar, which is the biggest. Here it's around 90 billion. No. Let's see, I have it here. Okay. Qatar is around 90 million tons of CO2 because they are big. They have surplus. They serve the world market with cheap fossil fuels, and when you take away their surplus, then less fossil fuels are on the market, a little bit. While, and this is now the interesting example of the United States, they're running big deficit. When we take away their deficit, global emissions decrease by around 80 million tons. But when you look only at this scenario, I now show you the map only for the single scenario, taking away the imbalance, the deficit of the US. Yeah. Then you see in each country what happens to their local to their national emissions, and you see that in the United States, emissions increase a little bit. So their overall effect on global carbon emissions comes from other countries decreasing their emissions because they do not export as much to the United States as before, and therefore do not produce these exports to the United States, as for example China, and therefore they do not cause as much emissions.
This is all simultaneously. As you said before, we have a picture, but only the United States.
It was wrong. Okay. So. Okay, I haven't the figure in this slide deck, but believe me, what I said was true. Yeah.
Fast for understanding what happens. So when an imbalance is set to zero, is overall production, overall consumption set constant? So the rebalancing is among different price, or it is a reduction in consumption and then a reduction in production.
Yeah.
So
Or
it is a shrinking of trade,
or an increase in export.
Yeah, it can happen. I mean, basically can happen everything, but it's highly likely when you have a deficit.
The environmental impact wouldn't that depend on how the model works?
So
in total consumption, total
Sure.
production.
Yeah, absolutely.
So what the mechanism is will determine how much the ecological impact is of this rebalancing.
Exactly, and also from the United States, when you take away their deficit, they produce more on their own, and because they have a relatively clean production technology to produce their goods, their production will increase, but the increase is not associated with that much emission increases.
But as I understood it, it's not assumed that the overall global production is fixed.
No,
No, because the production can change given the transportation costs and everything else. The only thing which is here assumed is that the United States have a balanced trade.
In all likelihood, it will reduce our production because in all likelihood, it would reduce global production if you balance that. Because
actually, I'm not sure. I thought I mean, just 10 seconds ago, I started to think about it.
because mostly you trade because it's cheaper to buy it from abroad than to produce it yourself. Even incurring trade costs, because if you produce it yourself cheaper, you would pretty much produce it yourself already before. So basically, what you do, you restrict trading balances, you restrict free trade, so it's very likely to reduce like global output. Not by the full extent.
No, it's right. It's right.
But it should restrict foreign trade.
Yeah. Yes, this is the one, and the ecological impact would also be if you restrict trade imbalances of oil exporting countries, for example. Then this is the same as you prohibit the use of fossil fuels. And then, of course, you have a positive ecological effect.
I mean, therefore, what the model, therefore, we introduced fossil resources as a production factor. So each country can decide on their own. I mean, can basically also start producing fossil fuels, which is more expensive. So obviously, as Qatar, but they can do it, and they also start producing primary fossil fuels, basically digging out resources from the earth.
What in the model drives the mechanism whether the United States balances its trade either by reducing consumption or by increasing production? Because then the ecological impact will exactly be the opposite.
Yeah,
and then I mean, determine which of these or what combination of these would happen. What is the
trade restrictions or like trade barriers? Trade barriers and comparative advantage and technology. I mean, which is comparative advantage.
Yeah, but for example, if you take again the United States, I mean, they do not import that much fossil
Not
would
anymore.
all from-
Not anymore.
Yeah.
But actually,
Because you said they have a cleaner production, which is not true if you think about extracting a fracking gas and all, for example.
Probably they would produce less of the fossil fuel intensive products, but produce more in other ways. I mean, it could be, given the underlying optimization process. I mean, you don't know what is going to happen there, right? I mean, it's a black box.
So they start importing cheap consumer goods from China. They stop and build it more on their own, produce more on their own. And they do this in a more cleaner way than China.
That's what you assume.
This is in the data.
That tells you.
It's just cleaner. It's not less.
It's not clean. Yeah, it's not.
But
It's like,
no, it's cleaner, but
Yeah.
it's not less.
They are not
So the
producing
amount
they
didn't
Well,
decrease.
It's likely.
it's likely a little bit less
Yeah, okay.
because
More expensive.
because a surplus is kind of a subsidy. I mean, you can consume more when you have when you have a deficit. You can consume more. Like it so to say, it is given to you when you're running a big. I mean, the US they can consume so much because they have like a very strong currency, and therefore it's super cheap for them to buy, and everyone lends their money, and therefore they consume more. And when you limit this ability,
I totally understand. I think the question here was what drives this reduction? Is it really just because they produce a given amount in a cleaner way than China, or is it also driven by a reduction of the whole production? Right?
Yeah.
And this was the question.
but this is we were talking about a minute ago that global production. So I haven't looked in the data, I have to say, but global production is likely to be a little bit less. While, for example, production will increase in the United States, production will decrease in China.
I was also wondering, can you say something about policy when you take on this? I mean, I think obviously would be interesting to see the figures, what the model tells us in terms of the reaction functions. So what happens to imports, exports, and local production and consumption patterns. That's probably a first step. But as of now, you have two scenarios. One scenario is the equal reduction in trade balances or imbalances, for that matter, the rebalancing of trade or balancing of trade. That is likely to decrease, as we just said, global GDP, and that reduces CO2 emissions. Well, that is pretty obvious. But this scenario seems to be more interesting. So this scenario, would you then be able to say that this scenario actually supports Donald Trump's America First and Mr. Biden's Build Back Better America policies, where you have strong decoupling tendencies, especially from China and international trade, more make locally, less buy internationally. Would this be good for the climate then?
I mean,
and this is the implication, isn't it?
So to say it is, yeah, because when you consider who runs the surpluses and who runs the deficits. I mean, Germany is an exception. Germany runs a big surplus. I mean, not anymore, but had to, and produced quite clean. So their surplus served, so to say, the world market with comparative cleaner products, while a lot of other countries running surplus are either fossil fuel exporters or China, for example, which produce quite dirty. And while the US running the deficit, importing and their imports are more carbon intensive. When you then would say, okay, and it's so to say, yeah, it's that would be the policy implication that when you when the US would source more from their own, global carbon emissions would likely decrease. Trump was right.
Given the time, have to yeah, because Anna had a lot of work in preparing comments.
Okay, so last scenario is, so this was the individual countries, and then last scenario is what happens when you take away all imbalances, aggregated imbalances, and then global carbon emissions would decrease by around 0.9%. The numbers to summarize. 0.9%, around 330 million tons of CO2, which is, and then when you say, okay, is this big number or not? It's around the annual emissions of France, which is the 17th largest emitter of the world. So quite a bit. And when you then compare, so even you see in the picture, this is now the national emissions, how they change, a lot of heterogeneity. Won't go into detail there, but when you consider 0.9% global carbon emissions reduction in global carbon emissions, is this doesn't sound that much. But when you compare it to, there's a paper of Joe Shapiro, basically calculating the total effect of international trade, which is when we would move to autarky, how much emissions would we save? I mean, or less emit. And then he says, okay, we would reduce global carbon emissions by 5%, which is like the extreme scenario, moving to autarky, obviously. And then when you compare 0.9% of this, then almost 80% of international trade total contribution to global emissions are due to imbalances that currently characterize world trade. So thank you very much.
Thank you very much, Hendrik. Would you be so kind to just jump into your presentation and
So hello everybody, my name is Anna Renhart. I'm also quite new colleague at WIFO. I joined in November, and I had the pleasure to read Hendrik's paper and provide a short commentary on it. I think given time, I'm going to skip the part I prepared on policies. I know that your model explicitly disregarded policies, but I thought for the discussion, it might be useful to look a bit at Klaus. You already mentioned it, the protectionist policies versus maybe some EU approaches that would be very interesting. But I think given time, I'm just going to skip right ahead to my comments. There are comments slash questions. I have to be honest, I don't come from a trade perspective at all, so this was quite a challenge to read. I think I discovered a new Greek letter in the alphabet. Let me just maybe start with the stylized facts. So you already mentioned it a bit in your presentation, so maybe you could explain again why you put the persistency of global trade imbalances in very prominently as a stylized fact. Maybe because it's something that's not really explained or not even considered in a model. And this is a bit of a standalone statement, maybe. And maybe you can, if you have to shorten your paper, this is something maybe you could take into account. I think it's a nice story for a presentation. I think it was quite interesting to see it. But maybe if you're a bit short on space, this might be a good thing to cut. Then I think you showed us a different correlation graph for figure 5. You sneaked that past. Yes, so I think the difference is a different data source. Is that correct? Yeah. Okay, because that
it's the same as the model.
All right.
So that's why I always wanted to do it. Yeah.
All right, because that was actually one of my observation points, that data, it was a bit unclear why you use two different data sets.
Yeah.
And where you started using the GTAP and where you started, where you stopped using the RIAT. So, right. Maybe you can discuss a bit on the data limitations you've had. I know that both data sets, they end approximately in 2014. I'm sure that's a data problem, but I think that's also some, or how would you view that as a limitation, or would you see it as a limitation in your model? I mean, the 2014, that's 9 years ago. How?
Yeah, it's
how would you respond to
so
that?
just a couple of weeks ago there was a new update release for GPAP, which then covered I think 2017 or 18, which is still 5 years back. But yeah, it's I get this question quite often, but from the theoretical point of view, it's so the database determines the I/O structure of each production in each country. So how much inputs are needed from which sectors, and I think we have technological progress. When you consider car manufacturing 10 years ago, probably didn't use that much batteries, but now they have a way bigger basket in their production. It's true, we cannot capture, but yeah, this is unfortunately the case with all I/O tables. It takes some time to construct. Yeah, and we think you can do a lot of tweaking with the database in terms of to get them to a more recent level. So you can take trade shares from trade data. We have them till almost last month, but then I mean you can do and you probably should do for doing policy analysis, but in order to have a model that is persistent, where you try to sort as much from one database. It's not about getting the most realistic numbers in a way, but it's more about getting to be consistent from your theory to the data.
I mean, it's not a policy recommendation.
Yeah.
I think you would make anyway. Yeah. Right, and then I've also looked at UNFCCC data. Have you also experimented with that, the CO2 inventory? Because I think it also has a quite nice sectoral structure, which maybe brings me to the points on your model. So I think the sectoral structure, it was quite interesting. Maybe you could even like split it up a bit further and to differentiate between the sectors. Because for now you only have basically 3 sectors. That's quite coarse, of course.
I mean,
Yeah.
I have 65 sectors.
Okay.
But they are production function. We have 3 different production functions.
Oh, right. Okay. That's sorry. That again.
Yeah, no worries.
Not an expert. I jumped into this a bit. Then I have a question on your functional form of your production function. You mentioned in the consumption function that it's basically the same whether you chose Cobb Douglas or constant elasticity of supply. I think that there are some papers available that would go a bit in a different direction that would show, oh yeah, well, there's first this substitution effect. So maybe you could expand a bit on that, or maybe.
Yeah, no, that's a good point. To be honest, this is something my co-author told me that it is the way, and he was quite confident. And I asked him, and he also explained it to me, but I didn't fully understand. He said, "Okay, it's like you can switch between the function forms. The implications are the same for you, whether you have a CES nest in your production function or 2-tier conductors function." Yeah, yeah.
Maybe you could precise it in a footnote, because I think that was kind of like, okay, this is a very standalone statement in the paper, and it was a bit okay.
I mean, he proved it to me actually, but it was it took him 15 minutes on the whiteboard, and
so not a footnote. Yeah, I think we've already brushed upon transport. So yeah, again, I think that we already discussed this question, whether this was part of the consumption footprint. And well, of course, transport, that pattern would of course change if you would rebalance the trading. So I think this is also something I think I would mention at least that this is this cannot be explained by a model, or this is a black box.
Yeah.
I think this was a bit of what's happening with transport. Okay. Yes, and I think I misunderstood the last point I made about the sectoral structure, because I think with the Leontief production function, I got that mixed up. So I think you can disregard that one. So yeah, those were my comments.
Thank you very much. And thanks for substituting funds on short notice. Our hero today. Perfect. So you already discussed all points, or do you want to?
Yeah, there was good points. I made notes on. Yeah, it's first point was very good. Get rid of the panel graphic.
That's goods and services.
Yeah.
So you have the transport sector within.
Yeah. Actually, I have to think about like what how the question was also like how to account the transport emissions for the footprints, and I do not have an ad hoc answer where they go. Actually, I have to think about. Well, I think they probably go to the production footprint because I mean.
The other question is how could I think of other services having CO2 emissions, like business services or something? What is counted there? Is it the use of, I don't know.
But it's also
of traveling around, or is it what is the?
I mean, service sectors in general also have all different kinds of inputs. Buildings, electricity uses. Fossil fuels, depending on your local.
And that's accounted for in the data.
Yeah.
Think of Bitcoin.
Bitcoin mining,
Yeah, okay,
exactly.
okay.
Okay.
Can you think of more primary commodities in your model?
Yeah, I start thinking about because I have the background in agriculture economics, and the commodities are at the core of that field. And yeah, I was thinking, for example, on how does land is affected by commodity trade. So to have an elastic land supply in the model. Yeah, because this is so we have natural resources as a production factor for the primary fossil fuels, and this natural resource is it's modeled extremely standardized. So we say, okay, each country is endowed by natural resources, and there's no cost associated with using them, with digging them out. There's no, we do not have decreasing or increasing marginal costs and so on.
We have one last question from the virtual audience. Gerhard, you raised your hand. I'm very sorry, I saw it just now.
Can you hear me? Can you hear me?
You're still muted. We can't hear you.
No, I'm not muted.
I can hear you.
You can hear me. Okay.
Stop.
Perfect.
Obviously, you can see me now and also hear me. Okay. Thanks for the presentation. My question pertains to the transport thing, and I wonder to what extent your results are driven by this. I always find it strange iceberg assumption, because I mean when you have the iceberg assumption, the carbon embodied in the transportation is in terms of carbon embodied in the product. So if we take apples and beef, apples would be a low carbon product and beef would be a high carbon product. transporting a ton of apples or beef probably costs the same in terms of truck time and fuel, but the difference when you have the iceberg assumption, the difference in emissions is outrageous, and it is not correlated in any way to the actual transport costs, either in terms of euros or in terms of carbon emissions.
Okay, good comment. Let me.
And one suggests why can't you just get rid of this iceberg assumption and have a combined product? You have the product and you have a transport service, and you sell it together. This is what you usually do in input output. Okay, thank you.
These iceberg type trade costs are at the core of these gravity type trade models. And actually, I have to dig quite deep in my head to give you the formal explanation for it. Probably Yvonne knows better. But what you also have to consider is we do the model is solved in value terms, so not in quantities. It's in values. And the thing is also your suggestion. So like your line of thought, it doesn't impact the emissions in the model, because whether you have high iceberg trade costs or low only depends the expenditure flows. So whether I send you 100 euros and only receive 80 as a value term because 20 is melted on the way, I sent you 100. I sent you 100, and we know the embodied emissions in these in the 100 in what I buy for 100 from you, and in the embodied emissions in this are dependent on all the intermediates and also in the transport, which is part of the intermediate input bundle from the goods I buy from you.
Mm-hmm. I'm not sure I understood you. What I mean is that the 20 which melt away from the producer to the consumer, that those 20 reflect very different carbon contents depending on the type of product. When it probably more reasonably should reflect the transport costs, either in terms of money and in terms of emissions. So 20 euros of beef have a much higher carbon content than 20 euros of apples. And so the iceberg
but then probably also the trade costs, they are not the same. If I buy
probably
if I buy $100 beef from you, it's different than $100 apple.
Yeah, sure. This is why I framed my question with how to what extent do you think that the iceberg assumption influences your results? If you have the impression that everything is fine, then I have to take your word for it. But I have my doubts that this is a very meaningful or plausible way if I want to address specifically the carbon emissions of trade.
So this is probably not the best line of argument, but it's because it's so common in the literature to do exactly that.
Sure. I mean, it was common to think the Earth is flat. I mean,
but actually, I think no. What I said before, I think it's actually not a problem.
Okay.
But I will start thinking about it, because for me it's. I mean, the emissions were, so to say, produced. I mean, they were caused when the goods were produced. So.
Yeah. Yes, but I have to produce more in order to get a certain amount here.
Exactly.
So if I source it closer, the additional amount I have to produce is lower.
Exactly, and therefore less carbon.
Yes, okay. If I look at one good, it's probably okay, but not if I compare it across goods. And this is what you do. Because when you say I balance my trade flows, then I have certainly structural effects on the composition of production, on the composition of trade. And these structural effects might be enough to upset the emission results that you obtain using the iceberg assumption.
Let me think about these.
I do.
I'm still not convinced, but yeah, I will start.
Okay, guys, I think this is a question to discuss later on. Given our time, I have to stop here, and maybe you all stop. Thanks again. It was a pleasure to have you here, both of you, and thanks for joining us today. Bye-bye.
Bye.